Welcome to The Explainer. You ever stop and wonder why cake batter just sits there, but in the oven it becomes, well, a cake? Or how a tiny spark can set off a massive fire? Today we're pulling back the curtain on the 5 key factors that control the speed of, well, pretty much everything. This is all about reaction rates, and trust me, it's way more connected to your daily life than you might think. Okay, let's start with a campfire. We've all been there. You can get kindling going with just one match, right? But try that on a big, solid log, and nothing happens. So what gives? The answer to that simple question is actually a core principle of chemistry, and we're going to break it all down. See, what you're really doing when you build a fire or bake that cake is you're controlling the rate of a chemical reaction. And we do this stuff all the time, completely on autopilot. Every time you cook dinner or even just stash leftovers in the fridge, you are playing the role of a chemist.
So what are these control knobs we have for chemistry? Let's jump right in with the first 3. We're talking about the basic nature of the stuff you're working with, its concentration, and its surface area.
First up, it's just the inherent nature of the substance. Some things are just eager to react. Take sodium, for example. This stuff is so reactive it literally catches fire on contact with air. That's why it has to be stored in oil. Then you've got the total opposite, like gold. It's so unreactive it can sit around for thousands of years and not even tarnish. And that, right there, is why we love it for jewelry. All right, next up is concentration. Think of it like a crowded party. The more people you pack into a room, the more they're going to bump into each other. It is the exact same idea with molecules. This is why you see those big no smoking signs near oxygen tanks in hospitals. The air we breathe is only about 20% oxygen, but pure oxygen, it makes things burn unbelievably fast. You're just cranking up the concentration.
And this idea brings us right back to our campfire. See? A chemical reaction with a solid can only happen on its surface. Kindling is just wood that's been broken down into pieces with a massive amount of surface area. That's why it burns so fast. This is also why something that seems harmless, like flour dust in a mill, can cause a huge explosion. All those tiny particles create an enormous surface area, just waiting to react all at once.
Okay, let's shift gears and talk about the one factor we're all super familiar with: temperature. This is probably one of the most powerful levers we can pull to control how fast reactions happen. Let's go back to that cake. The batter just sits there on the counter, right? But slide it into a hot oven and a complete transformation begins. So what's happening? Well, all that heat gives the molecules a massive energy boost. They start moving faster and slamming into each other with more force. And that speeds up all the chemical reactions that turn gooey batter into a fluffy cake. And here's a wild little rule of thumb for you. For a whole lot of common reactions, just raising the temperature by 10 degrees Celsius can actually double the reaction rate. Let that sink in for a second. A tiny little tweak in temperature can have a gigantic effect on the outcome. And, of course, the reverse is also true. Why do we put food in the fridge? To slow down those chemical reactions that make it go bad. It's the same reason a lizard or a snake is pretty sluggish on a cold morning. Their whole metabolism, which is just a big series of chemical reactions, slows way down when it gets chilly. So, we've talked about changing the reactants themselves and messing with their environment. But there's another, much more elegant way to control reactions, and that's by introducing a little something called a catalyst. You can think of a catalyst as a kind of chemical matchmaker. It's a substance that grabs the reactants, helps them get together and react more easily, and then it just lets them go, totally unchanged and ready to do the whole thing over again. This means a tiny, tiny amount of a catalyst can have a huge impact because it just keeps getting reused. In fact, you probably have one of these in your car right now. A catalytic converter uses precious metals like platinum to grab toxic exhaust gases like carbon monoxide and super quickly convert them into much less harmful stuff like carbon dioxide and water. It's a perfect, everyday example of a catalyst making our world a cleaner place. And guess what? Our bodies are absolutely packed with catalysts too. We just call them enzymes. These are special proteins that speed up pretty much every single reaction we need to stay alive. For example, an enzyme called lactase is what helps us digest the sugar in milk. Honestly, without these biological catalysts, life as we know it would just grind to a halt. So, let's zoom out. What's the big picture here? Why does all this matter? Well, understanding these 5 factors isn't just for chemists in a lab. It's literally the foundation of our entire modern world.
Just think about it for a second. We use these principles to make everything from plastics and rubber to life-saving medicines. We use them in our food to make cheese and beer. We even use this knowledge to keep ourselves safe, like managing dust in flour mills to prevent deadly explosions. We are constantly, and I mean constantly, manipulating reaction rates every single day. So here's the key takeaway. These aren't just some abstract concepts from a textbook. They are real, practical tools. When you understand these 5 factors, you start to see exactly how we control and harness the incredible power of chemistry to literally shape the world around us. So I'll just leave you with this thought. Now that you know the 5 main ways to control the speed of chemistry, what would you do with that power? Would you want to speed up how quickly plastic breaks down in the ocean? Or maybe figure out how to slow down the aging process in our own cells? The possibilities are absolutely endless.